Okay, today in class we did something called limited reagents. If you're watching this, you're either watching this because you were absent or you were just really confused. So if you watch this, maybe you can get a hang of it and you can go through it a couple of times, stop me, pause me, and maybe you'll catch on to the way we did it. I'm not going to go through the little example we did in class, which we did with the bacon double cheeseburger. We're just going to go and click through that and get into the true chemistry of it. So this was on the PowerPoint, just kind of to get you in the mind of what a limited reagent is. This PowerPoint has been uploaded, but a limited reagent, if you don't like the word reagent, you can use the word reactant. And the word reagent, the word reactant are the same thing. When you talk about a reagent bottle, all that is all my bottles that I have in the back of the room are called reagent bottles. They store the chemicals. So a limited reagent is of the two reactants that you're going to have, it's the one that you're going to use up first. It's going to determine how much of the product you can make. So you can copy these into your notes. The excess reactant is the reactant you've got plenty of, and several people in class refer to it as the one that you're going to have some leftovers. So we've got one that's going to use up all the way, that's the limited reactant, and one that you're going to have some excess. So we're going to learn to figure out which one's which, and then we're actually going to learn how to calculate how much excess you have going on. So here are the steps, and you can click through those. I'm going to get into the sample problem. But first is to balance your equation. The second one is to do two stoichiometry problems, and that is going to determine which one amount of your product you can make. Whichever one makes the smallest amount of the product becomes your limited reactant. Your limited reactant has to be a reactant. It cannot be a product. And then our last step is to figure out how much of the excess you're going to have left over. You do a third stoichiometry problem and then you subtract. That's going to determine how much you're going to use, and then how much you have left over will be the difference between what you have and what you use. For example, if you have $5 and you spend $4, you're going to have an extra $1 left over, so that's kind of the way that's going to work. So we're going to go ahead and click through the sample problem and work through it, and I'm going to go ahead and click through this I'm going to have to pause because I don't have my board turned on to be able to work the problem. So just have to be patient just a second. Let me get my board going. Got it where I can click, but not where I can write. Okay, so now back to where we were going. So you probably want to try to write this one and work this one with me. It says sodium chloride can be produced by the reaction of sodium metal and chlorine gas. And it says what will occur when 6.7 moles of sodium react with 4.2 moles of chlorine. First thing is to write a balanced equation. The second is we're going to determine which reactant is our limited reactant. And then the third question we're going to answer is what is the amount of product we can make in moles. So to write our balanced equation, sodium chloride is being made, so it's going to be a product. Sodium chloride is NaCl, sometimes referred as nickel, and that is NaCl, that is just pure salt there. It's being made from sodium, which is just Na. And then it says chlorine gas is Cl2 because it's diatomic, Brinkelhoff. And then to balance it, we need a 2 here and a 2 here. So our very first step is to balance our equation. Next, we're going to identify our given and wanted, and hopefully this will help you. You have two givens. The first given is that you have 6.7 moles of sodium. The next is that we have 4.2 moles of chlorine. The fact that you have two givens, that doesn't mean necessarily it's limited reactant, but the fact that sodium is a reactant and chlorine is a reactant, so you have two givens and they're both reactants, that means you've got a limited reagent problem. All that really means is you're going to have to do two stoichiometry problems. And so we're going to identify our wanted here. And our wanted is going to always be your product. In this particular problem, there is only one product. So it's real obvious what we're going to go to. We're going to go to NaCl. And since this starting out in moles, we're going to go to moles. So these are going to be, so if you start out in moles, you go to moles. If you start out in grams, you go to grams. So we're going to do two problems. We're going to do one with this one going to our wanted and another one with that one going to our wanted. So we're going to do two. We're going to start out with this one. And mole of Na will go down. To the top will be mole of NaCl. And in front of NaCl is a 2, and in front of Na is a 2. Since a 2 and a 2, they'll cancel. This is going to be 6.70 moles of NaCl. It is just a coincidence. It's the same number, and the reason it's the same number, it's 2 mole to 2 mole. So the mole-mole ratio is the same. It's the same number. So if I use this amount of sodium, this is how much sodium chloride can be made. We'll do the same thing, starting with the other given. This time mole of chlorine will come down. To the top is mole of NaCl, still going to the product. There is a 2 in front of this and a 1 in front of this. This becomes 8.4 moles of sodium chloride. Now, this amount of sodium, the most you can get out of this amount of sodium is this much sodium chloride. This, if we use all this up, we can get this. But unfortunately, we're never going to be able to get to 8.4 because once we make 6.7, the sodium is going to be gone. So what I told them is do 2 stoichiometries with your 2 givens, 2 stoichiometry problems, going to your product, and you're going to look and see which one made the least. Well, here's our least. Okay. And that was made by this guy. And that is actually going to answer 2 of our questions. And what I actually told them I would like them to do is to mark through this one, the bigger number marked through. I still want to see it, but I want you to mark through it if you won't be tempted to use it, because that's not going to be used in any of our problems whatsoever. So the first question says, which reactant is the limited reactant? Well, first off, it needs to be a reactant, so it's either sodium or it's chlorine. And the limited reactant is going to be the reactant that made the least amount of products. So our answer here is sodium. Technically it's 6.7 moles of sodium, but you can just put sodium because it said which reactant. We got either sodium. So I label this as my LR, which is your limited reactant. What that means is chlorine is going to be your excess reactant. That means you're going to have some extra chlorine left over, and we're going to actually figure out how much chlorine is going to be left over in a moment. So my first question, which reactant is the limited reagent? That is sodium. Next question, what is the amount of product you can make in moles? Well, look here. This is how much product, that's a product, and that's how much I can make in moles. So I've actually answered this question. Now, it has confused a lot of students because on the homework, I also then asked for grams. This is not an additional stoichiometry problem. Rather, you just take this answer and convert it to grams. And you should know how to convert moles to grams. That's not stoichiometry, that's just converting. Now, since this one didn't have it, I don't have that worked out, but I would just multiply those two to find grams. So on the homework, when it says find moles, well, that's going to be your answer from above. To find grams, you just convert it to grams. It's just a simple moles to gram problem there. Okay, so this one didn't ask for it, so I'm just going to go ahead and go with that. But on the homework, it will. So this wanted answer is actually going to be this, which is actually the answer we got going on here. Okay, so I can make 6.7 moles of sodium chloride. Well, how much sodium would I use? Well, I'm going to use 6.7 moles of sodium because that's what this equation says. Well, to answer my next question is going to ask, I'm going to go ahead and write it. It's on the next slide, but I'm going to write it for we won't have to switch. How much of your excess will you use? My question is, let me get it to click. How much of the excess, oops, I can't spell. How much of the excess will you use? In order to figure that out, you take your wanted that you found here and you begin with that. Because this is how much product you can make. You can make 6.7 moles of product. I know how much of the LR I'm using. I'm using all of it. I want to find out how much of the ER I'm going to use. In order to do that, this problem now is actually going to go to the excess reagent. And we found that to be chlorine. It's right up there. Excess reagent is chlorine. In our balanced equation, we have a 2 here and a 1 here. So this is 3.35 moles of chlorine. Think of like money. Your mom gave you $4.20 to spend. That's how much you were given. You're going to use 3.35 moles of it. According to that's how much it costs. That's how much this reaction is costing us. 3.35 moles. Because this is how much sodium chloride I'm making. And so that's going to tell you how much you'll use. The next question says, how much of the excess will you have? You could say leftover if you wanted. Well, 3.35 is going to react. If we go back and look, this is moles of chlorine. We were given in the beginning, that we had, I've already forgotten, what, 4.2 moles? We had 4.2, so you're going to go back to your given ER. You have 4.2 moles of Cl2. This is your given. And you're going to use 3.35 moles of chlorine. So much you're going to use. And to find out how much is going to be extra, how much is going to be excess, how much is going to be left over, you're going to subtract. You're going to have 0.85 moles of chlorine is excess. That's how much is going to be left over. Okay? So that's the answer to that question. Again, you can pause it and look at my work. I'm going to move on to the next one. I have answered these two questions. How much of the excess reagent will you use? And that was the 3.35 moles of Cl2. And how much will not react? That's how much extra we had, which was 0.85 moles of Cl2. Alright, our next example. Same problems going on. We have 1.855 grams of chlorine reacts with 3.205 grams of potassium bromide. What is the balanced equation? So you've got chlorine diatomic reacting with potassium bromide. We've got a single displacement reaction, so bromine is going to be kicked out. And potassium and chlorine are going to join together, and they're both ones. To balance, there's a 2 here and a 2 there. Single displacement. Alright, we're going to identify our givens. We got 2 of them, 1.855 grams of chlorine. Our other given is 3.205 grams of potassium bromide. And our wanted here, notice, a while ago we only had one product. We actually have 2 products here, so you got a choice. You can go to bromine or you can go to potassium chloride. But here's a very, very important but. If you will read ahead at some of the other problems, like this very next problem, it's going to be asking for grams of bromine. So if I want to save myself, I got a choice of bromine or potassium chloride. If I want to save myself some work, it would make more sense to go ahead and go to bromine. That way when I answer this question, I will have answered this question as well. See how this is starting in grams? Because this one's starting in grams, we're going to take this one all the way to grams as well. So we're going to begin. And grams, we're going to bring grams of chlorine down. This is mass, our favorite type of problem to do. This is 71. And on top, we're going to be looking for, there's mole of bromine and mole of chlorine. In front of those two numbers are ones. We're going to take it all the way to grams, and this is 159.8 grams of bromine, 1 mole of bromine. If you multiply that out, you get 4.175. Got 4 sig digs in this particular problem, so that's why I'm taking it out. 4. Okay, so there's that one. I can't stop yet. I've got to do 2 of them, unfortunately, and I'm sorry about this, but it's one of those things I am required to teach you. So you signed up for the course. We're going to learn it. Okay, here we go. Coming down is 119 grams of KBr from periodic table. That's 1 mole of KBr. And 1 mole of Br2 in front of, so 2 mole of KBr, 1 mole of Br2, and 159.8 grams of Br2. If I multiply and divide this, you get 2.152 grams of Br2. Alright, which one's bigger? This one up here. That can't happen. Just going to mark through it. Okay, so this is going to be one of my answers, and this is going to be one of my answers. First question says, which reactant is the limited reactant? Well, chlorine or potassium. So, potassium bromide, the answer is potassium bromide. So, because this is your LR, this is your ER, excess reagent. How many grams were formed? Well, we've answered that. 2.152 grams of Br2 can be formed. Okay, so when I do those 2 stoichiometries, both your givens to your product, we decided to do bromine because this question asked for bromine. Whichever one made the least amount, whichever given made the least amount is your limited reactant, and the amount of product is your answer, which you get down here. Alright, the next question is to figure out how much of your excess reagent you have that's going to react. I'll go ahead and go to that slide. Okay, here's the other questions. How many grams of your excess will be used? Your excess was chlorine, so you're going to start out with your amount of product that you made, which was this. And you're going to bring grams of bromine down. 1 mole of bromine equals 1. We already got these masses from before. And on the balanced equation is a 1. This time we're going to go to our excess. Our excess guy was chlorine because he was our ER. So we're going to go to chlorine. And there was a 1 in the balanced equation. Okay, so we're going to multiply and divide. We come out with 0.9561 grams of chlorine. This is going to tell you how much will be used. This is how much we're going to use, which is the answer to this question. This one is to say how much will not react, how much extra we're going to have. We go back up to our given information, and we had 1.855 grams of chlorine. This was our given, how much we have, and we're going to subtract how much we're going to use. This is how much you're using of it. So the amount you'll have extra is going to look like that. You could actually round that for sig digs based on decimal places to this, but I won't count off. So either one of those will work for me. On your homework, it's not going to ask you this question, but you have to do this before you can get to this. On your homework, it's just going to say how much is going to be left over of your excess. So you have to figure out how much you're going to use first and then subtract it. So this step has to be done before you can do it. Last part of this is percent yield. Percent yield, again, was the actual, which we say is actually lab situation, divided by the theoretical, which is stoichiometry. times 100. Okay, it says if you made 2 grams of bromine in lab, so since that says in lab, that's going to go on top. It's grams of bromine. We're going to divide it by some, and apparently I've done some stoichiometry. I've done a lot of stoichiometry, but I'm looking for grams of bromine. See this right here? That's not grams of bromine. That's grams of chlorine. Let's keep looking. That's not grams of bromine. That's grams of chlorine. Let's go back. That's grams of chlorine, grams of potassium bromide. Look, this one was grams of bromine, but I scratched through it. We're not going to use that number. Here's grams of bromine. Go back and find where you found the grams of bromine, and that's my grams of bromine. So we go back, and so in theory, I should be able to make 2.152 grams of bromine. I can only make 2 grams, so I'm going to divide them, and so we get 92.9% yield. Really good percent yield. I would like that, right? So this is all limited reagent. Unfortunately, it's 3 stoichiometry problems. You start with each of your givens and go to your product. If there's more than one product, read ahead. So we read the bromine. So we took them both to bromine. Okay, the one that makes the most you scratch through because that can't happen. When you do that, that gives you 2 answers. Your starting giving information is your limit to reactant, so KBR was our limit to reactant. The amount that it can make is the amount of grams you can make. Now to do the excess, you start with the amount you can make. You go this time to the excess reagent. That's going to tell you how much you're going to use. And then once you get that, you go back and start with your given information, subtract what you use, and that'll give you your excess. And then percent yield is your grams of your lab divided by your stoichiometry. You will have already done your stoichiometry somewhere in that problem. And that is all. On the last page on this PowerPoint, and I did upload it actually separate on Edmodo, but if you're looking on here, are the answers to the practice problem. I also uploaded the practice worksheet, so if you are absent and you're watching this, you can actually print that worksheet out and try it. That way you're not getting further behind. Okay, so if you need any more help, please come and see me. I can't help you if you don't come in. Okay, have a great day.